to demonstrate the difference between classical computers and quantum computers. So in any computer, classical or quantum, a bit can be represented by electron over here. Now, in a classical computer, the electron is either over here, 0, or over there, 1. It is definitely not 0 and 1 at the same time. But in a quantum computer, electrons very happily are both 0 and 1 at the same time. To see how this affects computation, let's suppose that electron over here says, do this. Let's tell all these other bits to make some interesting pattern. And now you see what we have is we don't just have one bit that is doing this and that at the same time. We have many, many bits that are doing this and that at the same time. So the quantum computer is doing two computations in some funky quantum sense at the same time. And, hey, there's no reason to stop there. Quantum computer is completely happy doing 400 or 1,000 or a billion or as many things as there are elementary particles in the universe all at the same time. The more the merrier.
Seth has spent the last 2 decades making this ordered rearrangement of quantum bits work in a real device. One that can do real calculations. The heart of this quantum computer is chilled with liquid helium and consists of a small superconducting electrical circuit known as a qubit.
This qubit is a little tiny thing. It sits in a tiny little gold package like this. And in the middle of it, there's a tiny little circuit which on supercurrent can go around like this forever, or it can go around like that forever. So we call supercurrent going around like this 0, and supercurrent going around like that 1, and supercurrent going around this way and that way at the same time, 0 and 1 at the same time. All this rack of expensive equipment here is designed to talk to the qubit by sending microwave signals to it, to tickle it and massage it. My job as a quantum mechanical engineer is kind of like a quantum atomic masseur. We massage these molecules in a bunch of different ways. If you massage the molecule the right way, you can get this wiggling and jiggling so that it's actually performing a computation. So the molecule, as it relaxes, oh, it feels so good, says, oh, if you really want these multi-lax movements, I'll do it for you.
Quantum computing is still in its infancy. In fact, multiple times 5 is the most complex computation Seth's machine has ever done. But Seth argues that his computer proves that subatomic particles can think, and that the universe, which is entirely built from such particles, must also be a quantum computer. It processes and stores information at the microscopic level of everything we see around us.
The universe is not alive. It's more alive. It contains life. It does all the things that living things do. It processes information. But the universe as a whole can do much more than just what living things do.
The human brain can perform about 10 to the power 16 or 10 million billion computations in a second. At the same time, Seth believes the universe performs about 10